everybody. In this video, I'd like to talk about pseudocode. To understand the purpose of pseudocode, I want to remind you that computer science is about problem solving. There's a specific problem that we really want to solve, and what we do is first we think about the parts of that problem and how we would go about writing out steps to solve it. That's the algorithm. Once we have that algorithm, then we can go to our computers and type up the actual program. Now, what you'll notice here is that the first two steps of problem solving just involve figuring out what's going on with the problem and then writing up the algorithm, which doesn't actually require the use of a computer. It's more important to think about the design of the algorithm with maybe pen and paper ahead of time before starting to write it up. With that, let's talk about what I would expect to see in pseudocode for it to be detailed enough to take that pseudocode algorithm and turn it into a program. First, you want to know what the input is and what the output is. So what are you putting into the algorithm and what are you getting out? Sort of like baking a cake. You want to put in ingredients, and as your output, you want a cake. Next, you want to see the steps that make up that algorithm. So with the cake analogy, this is going to be the steps of how you're going to mix together the various ingredients, what temperature you're going to bake it at, that sort of thing. Another thing you might like to see in pseudocode are the variables, which is just information you need to remember or use in order to continue with the algorithm. And maybe to think of more of another recipe example, if you were to make the frosting separately, you would want to hold on to it and then frost the cake at the end. That would be a variable that you were holding on to. The last thing that I have here is the properties that will allow a demonstration of correctness, which might be formally expressed as pre and post conditions and loop invariants. This one's a little bit more involved than what we've seen before, but basically you want to ensure that your algorithm actually gives you the correct outputs for the inputs that you give it, and so you want to make sure that some conditions are met ahead of time, and if those conditions are met, those are preconditions, then you know that the output will be right. So, if you were to go and replace one of the ingredients in your cake, it might not come out right. So these are other things that you have to keep in track of when you are writing that pseudocode. I have here an example. So the example format, let's say we are doing area of a circle. First, you would write the algorithm and give it a name. So I might call it algorithm area circle. And then think about your inputs. So the input that I know, we know that pi is equal to 3.14159, and maybe I've told you already that the radius r is equal to 1. Then the output is going to be the actual area. And from there, you can write a description of the steps needed to solve the problem. So go ahead and just start numbering by 1. And maybe the first step, knowing that area is equal to pi r squared, I would start by calculating r squared, which is just 1. And then I would multiply pi by r squared to get 3.14159. And then finally, I would return the area, which is, again, 3.14159. This is a very specific example where I've inputted the radius, but you can do this more generally without having a value for the radius there. Once you have the steps for that algorithm written out, you can start to write code for it. So I'll just go ahead and show an example of writing up Java code for doing area of a circle. I have public class circle area calculator, public static void main string args. And now I'm going to define the radius of the circle, which is going to be double radius is equal to 1.0. And then I'm going to calculate the area, which is going to be double area, which is equal to math.pi times math.pow radius in 2. So math.pi, when I wrote it by hand, was 3.14159, and then I actually wrote r squared, but in Java syntax, I want to write math.pi and math.pow instead. And then let's say I want to just print out the result. I can say system.out.print, the area of the circle is blah. And that ends that. So you can see how the basic math logic looks very similar to what I wrote with the pseudocode, but I didn't have all this Java syntax there. The pseudocode that I wrote was sufficient to help me translate it into Java code, but it itself was not Java code. So this is one thing I want to point out, that pseudocode is independent of the specific syntax of the programming language. Now, let's talk about the steps that I wrote out, which is the algorithm itself. An algorithm is a description of a finite number of steps to solve a problem. So I wrote like 1, 2, 3, 4, and I wrote some text after it. The algorithm that you write, even in pseudocode, is going to have certain properties that you want it to have. One is going to be, well, you want it to be correct, whatever you write. You want it to terminate, meaning that eventually, given an input, it will get to the output. It should be robust. It should be able to handle unexpected inputs. So this is where testing comes in. And it should match the program that you're going to write. So whatever level of algorithm you're writing with the pseudocode, it should be easy to translate that pseudocode into the specific programming language. If it's not, then you need to go back to your pseudocode and think about breaking it up even into more steps. The area circle one, since it wasn't very long, it didn't take me too long to take that pseudocode and translate it, but for a more complicated program, it might take you a couple of iterations to get there. And another nice thing for algorithms to have is adaptability. So if you change your problem a little bit, it should be possible to change your algorithm a little bit to solve a slightly different problem. And we do want algorithms to be efficient, which means for us right now that it just doesn't take too long to run. All right, so what we're going to do, and as we've already seen, is we're going to document algorithms using pseudocode in a not language specific way. We write our algorithms in pseudocode, which again is a high-level description of an algorithm, and it's going to combine natural language and structures from programming languages. It itself is not a computer program, right? So that's where when we saw area circle, the way I wrote it by hand thinking about it was very different from the way I wrote up Java code for it. Nonetheless, we do have a certain structure for our pseudocode to make it a little bit easier for us. Some of the notation that you can use that kind of looks like programming notation is in this table here. So for assignment, I have this left arrow, which means when you have a variable, you can set it equal to a value. For example, age is going to be set to 24. I have all my normal math operators of greater than and less than or equal to and equal to. That's something that you can use to do comparisons. I have a for loop for I from X to Y, do whatever it is you want to do. And then I have a for each X and Y, do whatever it is you want to do. I have an if statement, if X, then blah. A while loop, while X, do blah. You can have return statements and you can have comments. So you'll see here that it kind of looks like Java syntax or maybe another programming language, but not exactly. this makes it a little bit easier to read than Java syntax and also makes it more general so that you could write pseudocode and it could be applied to a different programming language. I will also point out that for this class, we're going to use indentation, not braces or brackets, to indicate blocks or control flow bodies. So even though there is not necessarily a structure for pseudocode in general, I'm giving you some examples of things that you can do to make it a little bit easier to know what to write when you're doing pseudocode. All right, so with that, let's look at a few more examples and hopefully it'll clarify a little bit more. All right, I have here an example of some Java code and then some pseudocode. What I want to point out here is that in the pseudocode, based on what I've told you, I want to name it, which is algorithm, and I called it get minimum grade. It takes in an input of G, which is an array, and it has an output. Now, when you write this in Java, it has a specific way to look. It is also called get minimum grade. And now I've written syntax with this like int and then these square brackets, which was not necessary in the pseudocode. And then after the input and output, I've written some steps that I needed, and I'm allowed to have the assignment operator, and I'm allowed to have for loops, and I'm allowed to have returns. And you can, if you want to pause the video and do a comparison between these two, you should be able to map them between each other. But this gives you a sense of, for a relatively short program, the level of detail that's needed. In fact, the pseudocode is not that much less detailed than Java. It's just that it's set up in a certain way, so it's a little bit easier to read out loud. Here's a bad example that's a little bit longer than what we've seen before. So this is something called weighted edit. So the algorithm is called weighted edit. It takes an input, it has an output, and one thing that's actually kind of nice here is that the variables that are used are listed. But if you start looking at the description down here, it's not really super clear what's going on. In fact, it looks a little bit too much like actual code to be so easy to read. It's also not indented correctly, and these variables don't have very good names. Like L1 and L2 should have longer names to make it easier to see what exactly there are. So this definitely looks something more like you would actually type up, that a computer would be able to compile, but not really human readable. One thing I do like is that up here it does name the algorithm and then it says what it's supposed to do. So that's actually also very helpful. And I do think it has like the right number of steps. It's just that these steps should be explained out a little bit more. Some comments would be helpful. Let's go over a couple of salient points with pseudocode. Pseudocode is a kind of structured English for describing algorithms or structured natural language. It allows the designer to focus on the logic of the algorithm without being distracted by details of language syntax. Even though you are not thinking about language syntax, pseudocode should be specific enough to describe the entire logic of the algorithm so that when it comes to implementation, it should be a rote mechanical task of just translating line by line into source code. So this part's a little bit funny. We don't want to use Java syntax and think about Java specific things, but we do want to think specifically enough to be able to translate it into Java right away. And another thing to point out is, in general, the vocabulary used in the pseudocode should be the vocabulary of the problem domain, not of the implementation domain. So that's another way to say that we don't want any Java-specific syntax in our pseudocode, but you can use any language that has to do with the problem that you're solving, right? If there are if there's a specific object that you're counting, or a specific type of number that you're calculating, that kind of vocabulary can go in your pseudocode. The last thing I want to say about pseudocode is that we should try to be as descriptive as possible. So I've given a couple of examples, but you can add details to those examples. For example, you can write in English, extract the next word from the line, which is very descriptive, which is a little bit better than set word to get next token, because token is sort of a Java-specific word, and so it's not as clear what is happening there as compared to the first line written. Another example is append the file extension to the name. That's pretty good, pretty descriptive. But if you write name is equal to name plus extension, that's not as descriptive as to what's going on. You can certainly use these together. For example, you could say name is equal to name plus extension and then write a comment saying append the file extension to the name. Right? And now you have a lot of description and something which maybe resembles something more like code. And then even in your for loops, you can also be more descriptive, and you can remember to have descriptive variable names. So for all the characters in the name is pretty good. For character equals is first to last is okay, because it got rid of the word name in there. It's hard to remember maybe that the characters are going through someone's name. In conclusion, algorithms must always solve the problem, no matter what the specific parameters are. Algorithms must be written in pseudocode to help you analyze the algorithm. So that's to help you find logic errors versus syntax errors. Syntax errors are going to appear once you start programming, but they should be a non-issue when you are writing your pseudocode. You should be able to easily translate an algorithm into any programming language, so it should be sort of independent in that sense. And finally, there's not really a standard way to do pseudocode. It's a mix of keywords and natural language. I've given some guidelines for what I would like to see based on just what keywords I would expect to see and what kinds of operators you can use, and given some examples, but you even notice that not all those examples had exactly the same style. That's something you're going to develop over time, and you will see what makes it easiest for you to turn pseudocode into an actual programming language code. Thanks for watching.